In the previous lesson, we have seen that a power x equal to y is represented as log y to the base a is equal to x. So this is the general representation of a logarithm. So now let's consider these two cases. The first case, we have a power m is equal to x. So this can be represented as log x to the base a is equal to m, right, based on the general representation. Similarly, a power n equals to y is represented as log y to the base a equal to n. So the exponent of the base is the logarithm of that number. Let us assume this as 1 and this as 2, and now let's multiply 1 and 2. So you will have xy is equal to a power m multiplied by a power n. But from the laws of exponents, we know that this is nothing but a power m plus n. So let's call this 3. So from 3, we know that a power m plus n is equal to xy. So now again, this is in the form of a power x equal to y, where x is equal to m plus n. So this can be represented in logarithms as log xy to the base a is equal to the exponent, which is m plus n. So now let's call this as 4. So on the right hand side you have m, but we know m is log x to the base a, and we also know n is log y to the base a. So substituting m is equal to log x to the base a and n is equal to log y to the base a, we end up with this equation, which is log xy to the base a is equal to log x to the base a plus log y to the base a. And this is the first law of logarithms. Now let us look at the second law. So again, let us consider the same three statements that we have seen before. This is the general representation of a logarithm, and we are taking the same cases 1 and 2, where a power m is equal to x is represented as log x to the base a equal to m. A power n equal to y is represented as log y to the base a is equal to n. So now let's divide x by y. So when you divide x by y, you have x by y is equal to a power m by a power n. But by laws of exponents, this is nothing but a power m minus n. So again, this is in the form of the general expression as you have seen here. A power m minus n, where a power x is nothing but a power m minus n, and y is nothing but x by y. So this can be expressed as a log of x by y to the base a is equal to m minus n. So substituting m again as log x to the base a and n as log y to the base a, we have log x by y to the base a is equal to log x to the base a minus log y to the base a, and this is your second law of logarithms. So in the first law, we have seen that log xy to the base a is equal to log x to the base a plus log y to the base a. In the second law, we have seen that log x by y to the base a is equal to log x to the base a minus log y to the base a. Now let's look at the third law of logarithms. The general form of a logarithm, as we have seen earlier, is a power m equal to x is represented as log x to the base a equal to m. So now let's raise the power of the left hand side and right hand side to the power of n. So a power m whole power n is equal to x power n. We are raising the power of both left hand side and right hand side by n. So now if you observe this, so if you remember the law of powers in exponents, a power m whole power n is equal to a power mn, where we take the product of the two powers. So the left hand side becomes a power mn and the right hand side is still x power n. If you observe this, this is in the form of the general expression itself, where m is nothing but mn, and if you consider x power n as one single number, it is exactly in the form of a power m equal to x. So where m is nothing but mn and x is equal to x power n, and we know that this expression can be expressed as log x to the base a equal to m. So we can do the same thing here and represent this as, here x is nothing but x power n, so log x power n to the base a, as you have already seen, is nothing but m, which is mn, right? So this is what we will end up with. Now we know that m is nothing but log x to the base a. So substitute that. So now we will have n times log x to the base a. So basically we end up with log x power n to the base a is equal to n log x to the base a. And this is your third law of logarithms. So let us recap. So we have seen three laws of logarithms. The first law states that log xy to the base a is equal to log x to the base a plus log y to the base a. So which means the log of product of two numbers is equal to the sum of the logs of the individual numbers. The second law states that log x by y to the base a is log x to the base a minus log y to the base a. So again, this is logarithm of division of two numbers is equal to the difference of the logarithms of the individual numbers. And the final law states that log x power n to the base a is equal to n log x to the base a, which is log of the power of a number is equal to the product of the power of the number and the logarithm of that number, right? So these are the three laws of logarithms that we have learnt. In the next lesson we will work on few problems which will apply these laws of logarithms.